In this video, we will discuss how to simulate XRD data from a CIF file using GSAS-II. You know that GSAS-II is a free software package, and if you want to download this open source software for XRD data analysis and plotting, then this video will guide you on how to download and install it. For this process, we only need the CIF file, and the CIF file can be downloaded from many sources. Among all these sources, I prefer the materials project. So you go to the materials project, and inside the materials project, you will be able to download the CIF file. If you are not logged into the materials project, then it will require you to log in here. So you can log in there first, and then it will show you the periodic table. And here you select, let's say, I want to download barium titanate in a simple structure. This one, barium titanate. So I select barium, and then I select titanium from here, and then oxygen. So when I search, it will show me many CIF files here, and the star means that they are experimental, while this one is theoretical. And I want to go for the simplest structure. So let me choose a cubic structure of barium titanate. And here, there is no cubic structure. So let me go to the next page, and here I can see that among all these structures, I have this experimental one, which is a cubic structure. So let me open this structure, and here it shows the cubic structure of barium titanate. And to download the CIF file, you click here and select CIF. So it has downloaded the CIF file here. And let me open this CIF file. So it is here. If I open this CIF file with Notepad, I can see the file here showing all the necessary information. It contains all the required details. And now I will go to GSAS-II and import this phase first. So let's start GSAS-II. This is the bash window used for starting GSAS-II, as it is based on Python. Here we have the control window, and here is the graph window. So the very first step is to import the phase from the CIF file. And I open the barium titanate file here. And it asks, is this the file you want? Do you want to read the file? So yes. And it shows barium titanate. And I say OK. So the phase has been imported, and we now have all the information about this phase. In the journal phase tab, we have the latest constants. It is cubic, so all the latest constants are the same, along with the angles and all the information. Similarly, we have all the atomic coordinates listed here. Now the next step is to import dummy data. The dummy Porter data will essentially be the simulated data. But if we do not import dummy data, we will not be able to simulate this phase. So we go to import and then to Porter data, and here is the dummy data option. So we select simulate a data set. We leave this blank because we are simulating the phase, and it asks for an instrument file. So for the instrument file, we click cancel. We do not have the instrument file here. Now the next steps are the usual settings. So we confirm that copper K alpha is selected. Here we can change the starting angle, ending angle, and the step size. I will keep all the settings as default. And it says that now you can calculate and refine to compute the simulation results. So we are here now. And if I go here, I can make some changes. For example, I can change the starting and ending angles background, and other parameters that we usually adjust. But our objective here is only to simulate the phase. So the first thing is to click Calculate and Refine, and it will prompt you to save your file first. So let's save it as CIF to XRD. This is just to save the project file. And it has started generating or simulating the XRD data. And I see it, okay. So it will display the pattern like this. And when I click, for example, the background tab, then I have the XRD data here. And I can check this. Let me show it here. This means I can check that we have the experimental data shown with the plus symbol, and then it fits with the calculated data. So we have the data ready here. Now, if I want to use this data to plot it elsewhere and show the difference between the two, I can do that as well. So I click the data, and here I go to export, and for powder data, let's say I export it as a text file. So it will export the data as a text file, and let me save it. So now we have the XRD data file here. This is the CIF to XRD data, and here we have the two data values. The experimental data is Y observed, and this one is the calculated data. So we have all the data here, and if I want to plot this in another software, for example Origin, then let me open Origin. And here I can import the data from a file using the import wizard and go to the location of this file, or simply drag and drop it. And here it is. We have the data here, so I can select this column and then Y observed, and I can plot this. And here is our data. I can zoom into the data here. We can zoom in on a peak, and we can see that the data appears like this because it is simulated. But the calculated data will be smoother. So let me plot both to compare them. So here is our data, and we can now clearly see how the experimental and calculated data match. So here it is. The calculated data is smooth, and this is the way we can simulate XRD data from a given phase. Now this calculated data, the smooth one, or even the experimental data can be placed as the PDF card showing that this is the simulated XRD pattern. Instead of only lines, we can use the actual data in place or experimental data on top of it to show the peak positions, etc. The same process can also be done in VESTA. With VESTA, we can generate the simulated pattern, and we will show that in another video. Thank you for watching this video.